All right, everyone, the beginning of Chapter 2 deals with solving equations. So we're going to work on a few videos today. I'm outside, which is awesome. It's the beginning of August, so it's still summertime. But let's go ahead and start solving some equations. All right, everybody, if the audio is a little different, I'm recording outside today. It is a humid day here in the beginning of August, but I'm thinking ahead to Chapter 2, and we're going to be solving one-step equations. Now, the first thing I want to mention is that you can look back and see video 1-8, where I go through each of the 4 types of one-step equations, so that might be a really good resource for you. If you need a little bit more, I've given you 2 different problems here that extend our knowledge a bit. I'm going to show the first one 2 different ways and the second one way, and that'll be that. For one-step equations, if we were going to make these difficult, we might include decimals, we might include negatives, or as you can see here, we might include fractions. Now, decimals, you'll probably rely on a calculator. Negatives fall back on the basic rules of multiplying and dividing, adding and subtracting negatives, but the fractions give you something a little bit different, so I want to show you 2 techniques to use. The first one, if I see a fifth of x equals 2/9, one idea is to multiply both sides. Now this is a little strange, but to get rid of multiplication we would normally divide, but I'm going to multiply by my denominator. Now you could even argue that I'm multiplying by the reciprocal of 1/5, which is 5/1, and that would be a little more flexible if my problem weren't 1/5, because what would happen is the 5's would cancel, but the 1's would cancel, or whatever that number would be. It would cancel out as well. A 1 would remain behind, which again isn't really needed, and then I'm going to get x is, now over here I'm going to look for cross canceling. I don't see any, so I'm going to do top times top, bottom times bottom. I'm going to get 2 times 5 is 10. 9 times 1 is 9, and if you're in an algebra class you can probably leave it as 10/9, or if you want or your teacher needs it, you can give it to them as a mixed number. Now I want to show the same question using a different technique. I'm going to switch colors, and here's a different technique. The other one we could use would be the idea to clear out fractions. And to clear out fractions, this one doesn't really come into play, but I'll show it anyway. You take your common denominator of these 2. Now the common denominator of 1/5 x and 2/9 would be whatever 5 times 9 is. Now you could probably, if you were a purist, you could probably argue that the least common denominator would work well, but the truth is the common denominator works just as well. My marker's dying off, but we'll see if we get through this. Now watch what we have here. The 5 goes into 45 9 times. This 9 over here goes into this 45 5 times, and watch what we get. 9 times x equals 2 times 5. And you can see that we're then going to do one more step. As my marker dies, the problem is almost over, and I'm not going to rewrite it because you see x is 10/9, which is what we set up here, or again you could do 1 and 1/9. Now you might wonder why we would bother doing that here. In this problem you might not need to, but in problems that have more fractions or more steps, that clearing out fractions idea is going to be something we're going to revisit. As for the third problem, since I'm changing colors, let's go ahead and change it one more time. For this third problem here, I'm going to use that same idea to some degree that I did in the first one. I'm going to multiply, but I'm going to do a kind of a combination. I'm not going to multiply by the reciprocal, only because I want to show you something different. So I'm going to multiply by the denominator only. In this case, I'm going to go ahead and do 9 goes into 9, 1, 1. So I have 4a equals, now here's where I run into problems. 36 times 9, I don't really know this, and I'm working without a calculator, so 4, 5, 27 and 5 is 32, so I get 324, and now I'm going to end this problem by dividing by 4. Now once again, some of you can see that we might have been able to use the reciprocal. Heck, it might have even been easier, but I want to show you some different approaches. 324 divided by 4, let's see, 324 divided by 4 is 8, 32, and 1. So we have 81, and we have our answer. So once again, I would encourage you, if you need anything other than what I've shown you here with a couple different ideas, go back and look at video 1-8 for a review of solving one-step equations.